And the last point, -1, 8. The y value again, we want to match up with a x value. We have a y value of 8, but the 8 we want to match up with a x value of 8. Since there are no 8's in the f function, this point does not map, or there is no composition for this point, so we'll leave this point off the answer, and our final answer will only be 3 points. 0, 0, 8, 3, and 3, 3. Title of the first section is Combining Functions. In this section, we'll combine functions by using operations in mathematics. First function we'll look at, f of x equals x squared plus 6x plus 9. And second function, g of x equals 2x plus 6. The first question we'll look at to combine functions will be f plus g of x. For this problem, f plus g will be adding the two functions f plus g. Combine like terms, we have a single x squared. Adding the x's together, 6x plus 2x would be 8x. And adding the constant numbers together, 6 plus 9 would be 15. So our final answer, after adding the functions, x squared plus 8x plus 15. Second question, and last question for the section. F divided by g of x. For this question, we can write the functions out. F is x squared plus 6x plus 9 divided by g, which is 2x plus 6. To solve this, we could use long division to divide these out, or a shortcut. Since both of these expressions factor, we can factor and then divide. For example, the numerator, x squared plus 6x plus 9, if we factor using the diamond method, two numbers that multiply to get 9 and add to get 6, those numbers would be 3 and 3. So the numerator will factor to x plus 3 and x plus 3. The denominator, 2x plus 6, we can take out a common factor of 2, and dividing by 2, we're left with x plus 3. Dividing from here, we can cancel one factor of x plus 3 with another factor of x plus 3, and we're left with our answer of x plus 3 over 2. Title of the next section is Composition of Functions. Composition of functions, we'll end up taking the composition, which is a different function, on top of the functions. First question, if f of x equals 4x and g of x equals 2x minus 1. Find. The new notation will be f, and a composition symbol will be an open circle, g. So this will be f composition g of x. To find f composition g of x, the new symbol again, a open circle. What we'll end up doing is taking the right side of the function, which is g, and we'll take the g function and plug it into f. For example, g, which is 2x minus 1, we'll take the expression 2x minus 1 and plug that into the variable for f of x. So for example, if we take f of x, which is 4x, but instead of x, we'll replace that with the g value, which is 2x minus 1. Simplifying this will give us the composition. And again, we'll take g, whatever that value is, plug it in for the x value of the other function, and then solve. Simplifying this, 4 times 2x would be 8x, and 4 times a negative 1 would be minus 4. So our final answer, f composition of g, is 8x minus 4. Second question, find. We'll do the opposite, which is g composition of f of x. Again, when we have the composition function, we'll go from right to left. So we'll take the f function and plug that into g. The f function again is 4x, so we'll take the 4x and plug that in to the other variable. So the g value, which is normally 2 and then x, but instead of x, we'll plug in 4x, and minus 1, which is left over from the g value. So taking the value of f, plugging that into the variable for g, then we can simplify to get our answer. 2 times 4x would be 8x, and minus 1 stays the same. So our final answer is 8x minus 1. And last question for the section. Find the composition g, composition f of 3. To solve this problem, since we have a number 3, we can either take the 3 and plug that into the f value, which will give us a number, and plug that number into the g value, which will give us our final answer. Or, since we also did the g composition of f in the previous problem, we can plug the 3 into 8x minus 1. So taking the previous function, which again is the same as g composition f, we'll plug a 3 in for the x, which will be 8 times 3 minus 1. And we'll have 8 times 3, which is 24, minus 1 gives the answer of 23. So g composition f of 3, the value is 23. Title of the last section today is Composition of Points. In this section, we'll take the composition using sets of points. In this question, f, instead of a function, f equals a set of points. The first point is 3, 8. The second point is 4, 0. The third point is 6, 3. And the last point is 7, negative 1. The second function, or second set of points, which is g. The first point is 0, 4. Second point is 8, comma 6. Third point is 3, comma 6. And the last point is -1, comma 8. Taking these sets of points, we can do the compositions. The first problem is find G composition of F. Compositions again, we'll go from right to left. So again, we'll take the F and plug that into G. When we have sets of points, we'll look at, starting with F, the first point, which is 3, comma 8. The 3 will be the X value and the 8's the Y value. What we'll do is we'll match up the Y value with a X value from G. So 3, comma 8, if the Y value is 8, we want to find a X value of 8 in the other function, which will be the second point, and that Y value is 6. So 3, comma 8, matching it up, goes to 8, comma 6, and the answer will be the X value from the F and the Y value from the G. So 3, comma 8 goes to 8, comma 6, so the answer would be 3, comma 6. We'll take the X value from the F function, the first function, and we'll take the Y value from the second function, the G function. Continuing on, we'll do that for each of the points. So the second point, which is 4, comma 0. Again, 4, comma 0, we'll look at the Y value, which is 0, and we'll match that up with the X value that's also 0. So 4, comma 0 will match up with 0, comma 4, since the Y value matches up with the X value, and our answer will be X, comma Y, using the X from the F and the Y from the G, which would be 4, comma 4. The third point, 6, comma 3, and again we'll match the 3 up with the X value in the G function, which would be the third point. So 6, comma 3 will match up with 3, comma 6, matching the Y value with the X value, and then the answer will be X, comma Y, or 6, comma 6. And the last point, 7, comma -1, matching up the -1 with a X value of -1. So the Y value matches with the X value. The answer will be X, comma Y, using the other numbers, which would be 7, comma 8. So 4 points, and we have 4 answers. G composition of F is equal to 3, comma 6, 4, comma 4, 6, comma 6, and 7, comma 8. Second question, and last question for the section. We'll do the same process, but we'll do the opposite by finding F composition of G. Again, F composition of G means we'll start with G this time, since we go from right to left, and we'll match the G points up with the F points. So starting with the G values, the first point is 0, comma 4, and again we want to match the Y value up with the X value in the F function, which matches up with the second point. The Y value is 4 and the X value is 4, and then the answer will be the X, comma Y, using the other two values, which would be 0, comma 0. Continuing on for the 4 points in the G function, 8, comma 6, again matching up the 6, the Y value, with a X value of 6, and the answer would be 8, comma 3. The third function, or third point, 3, comma 6, matching the 6 up with a X value of 6, we'll also have 3, comma 3.